So, welcome to lecture 4 on the Introduction to Agent-Based Models course. This lesson's, of course, it's a continuation of the previous lesson, and we're gonna focus now on the code tab, and we're gonna build our first model. So I hope it's quite an exciting lecture. We're gonna see things happening as we code, so that's gonna be cool. Just to start, like we everything we've done so far was done at the command center, at the interface tab, and I bet you've noticed that like there is no memory in there. So like if you create turtles or if we execute a sequence of commands and we restart NetLogo, we are going to basically lose all we've done. There is no way to keep it safe. And that's why we need the code tab, because on the code tab, we basically have the chance to code the procedures permanently in such a way that like when we save the file, next time we open it, the code is still there. We don't need to type everything again. So that's how it works when you do programming in other languages as well. Like you don't always use the terminal to type command by command. You usually have like a file where you have like the sequence of the commands all together. So the procedures, they're an independent code module, and the goal is like to fulfill some concrete task, and usually it's made of like a body of source code. So the procedures usually they are limited by a beginning command and an end command. And within this beginning and end command, you have a lot of instructions or a lot of actions your code has to do in sequence. So that's basically how it goes. And just to start, like the most basic procedures in NetLogo, I think you can guess they're basically they go in the setup procedures. So like every or almost every NetLogo code, it's gonna have like the setup. And just so you know, like when we are writing procedures in NetLogo, we always start using the to. Like the to is like the keyword to start your procedure. So it's a setup is the name of the procedure, of course, and then we have an end. So everything we write within, like between to and end, it's going to be the procedure setup. And we also have a procedure called go. And we have these two procedures here, basically because they are the standard buttons we put on the interface. You're going to see it in a little bit. Okay. You can notice that NetLogo has an indentation function here. So like basically when you type stuff, it kind of put it indents automatically, and that's because this box here is ticked. So if you untick it, it's not going to do it possibly, but keep it like that. And on the setup function, mostly always the first thing we do is like we want to clear all, because every time you hit setup, you want to basically remove everything you've done before. If there is any remaining agent or any remaining configuration on your world from previous simulations, you want to clear it all. So you can use clear all, or you can use just CA for short. So then you basically start the world fresh and blank. That's how it goes. And then let's say like at the beginning of the setup, let's create a group of turtles. So we know that like we have the command create turtles. That's the command. We can create like 100 turtles. Let's just use the short here. So CRT is create turtles, short for create turtles, CRT. And one thing that's interesting on NetLogo is that you can basically create turtles and immediately give them some instructions or ask them to do something as soon as they are created. So to do so, you just basically, after you create the turtles, you open the brackets here, and then all the commands you put like within these brackets, they're going to be executed by all the turtles as soon as they are created. So like, let's say here, I want to basically set the origin of the turtles to random X core and random Y core. We've seen this command before. This basically like defines that the turtles should be on a random place in the world as soon as they are created. I also want to define the color of the turtles. Let's say I want to set the colors to blue, and let's say I want the turtles to have a shape, and the shape is the shape of people. I want them to be like people. We've seen the last lesson that like we have the turtle shapes editor here, where you have like a lot of options of like shapes you can get, and you have like also people somewhere here, like the person here. So person is the singular for people, of course, and so the type's called people, and then you can just like choose whatever you want as the shape. So we want them to be people here. Okay, so one important feature of NetLogo is the check here, this button, the check button here. It basically helps us to debug the code, and then when you click on it, like on it, it basically checks if there is any error on your code. It could be like a typo, or it could be like a variable that you've used without declaring beforehand. So it's going to help you to keep your code working and functioning well. So if we go back to the setup here, and then we go here in Command Center and type setup, we're basically calling the procedure we just created. And as you can see here, we've made a mistake. So it's saying here that people is not currently defined shape. So that might be because it should be called person and not people. So let's see if it goes now. So setup, and there you go. So now we have 100 people distributed randomly in the space, and they are all blue because I decided that they're going to be blue. So every time like you type here, you're calling the procedure. Well, a better way of doing so, instead of coming to the command center and typing stuff in here, is just to create a button. So you can create a button by coming here, button, add, and then you decide the place you want to put it, and then it's going to open this box here for us to fill some gaps, some stuff. So in this box here, we have the commands. Like, so when I click this button, which commands the NetLogo is going to execute? So I wanted to just call the procedure setup. And we can also give a name to the button. So here, like if you leave it blank, it's going to be the name of the command. It's automatic. But you can even like say like another name. And if you change the name here, you can see that the bottom is going to have that name. So sometimes it's useful to do that. Mostly just keep it blank. It's fine. And then you click OK. So that means like every time I click on setup, I'm basically resetting the world. Like I'm clearing all, creating 100 turtles, sagging their positions to a random position, sagging their colors to blue, and making them of the shape of people, basically, which is person actually. Okay, so that's set up. Instead of typing here, just click on the button. We can we can create another button here, which is going to be the go button. We know that we're going to need it like soon because we even created the procedure here already. And the thing is, one important thing is like on NetLogo, besides the info tab, it's very important that you create a habit of commenting your code. So if you use like semicolon, yeah, I think that's the name. You got it. If you use it, this symbol here to in front of some commands, it becomes comment. So NetLogo basically ignores everything that's after the semicolon, and it treats it as just like a comments from the code that should be ignored when running the code. So I can even say here like ask turtles to be placed in a random X, Y position, and we can even make it like a even more mathematically interesting by saying that those are the coordinates of the turtle, and so on and so forth. So you can comment stuff. Okay. So now we should like implement the go, the procedure called go, which is going to be called when we click on that button or when we go to the command center and type go. And here, what we want to do is going to be a very simple code. We're just going to ask the turtles every time you click on go to go forward 5 steps, and to rotate to the right on a random angle of up to 90 degrees. Okay, so here it's forward 5, so move 5 steps ahead. This command here basically says like to the turns to turn their headings a random degree from 0 to 90 degrees. Okay, so the turtles are gonna rotate from 0 to 90 degrees, and every time you click on go, they're gonna do the same. They're gonna go forward 5 and turn a little bit, and so on and so forth. So if we click on check here, it says that the code's okay, there is nothing wrong. We go back here, we can click on setup, and every time you click on go, you see that people basically move. If you want to see like a slower, we can even do that, like turtle by turtle, they basically turn to the right from 0 to 90 degrees, and they move forward 5 steps. That's how it goes. Actually, they move 5 steps first, and then they turn 90 degrees. Okay. Just notice that we could also do the same by coming down here and typing go. But of course, it's much more interesting to just like use a button. It's much easier. And you can also, there is a specific attribute for the go button here, which is like this forever box. So if you check the forever box here, that means that the command's gonna keep running forever. So it keeps executing that command, like it's gonna be calling go, 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 go one time after another until you push the button again. So when you click here, for instance, you're gonna see that people keep moving, forever basically. And when you click on the bottom again, they stop. So that's how it goes basically. That's how it works. Like and even have the symbol here, like the loop symbol here, to show you that this button, if you click on it, it's gonna call the commands like many times until you click on it again. Okay. Important thing is to save. So every time you do something important, of course, just go there, just save the freaking code, because like if something happens, your computer blows up, or like the internet goes off, or the electricity goes off, or your computer stops working, or anything goes wrong, your dog eats the computer, you need to have a way to keep it safe. And the safest way of doing that is saving your code. You can create versions as well. So you can, for instance, use save as. Like let's say you finish the first model, so I want to call this code 1, and later if you want to create another version, you call it code 2. Of course, you can use SVN or GitHub or other tools like for version control, but like you can also just use like a NetLogo saving options, creating your own version control to keep your code under control. All right. Any questions so far? Oh, good. Just remembering that, like you by this time you should have done the tutorial. So I guess that most of these things here you possibly saw there. Questions? All right.
I have one.
Okay, go ahead.
But it's not about the material. It's about the grades.
Okay, so let's leave it for last. Okay.
Okay.
By the end of the lecture, you can ask me, just so we can keep things together. All right. Next part of the lecture today is about properties. And as we can see here, like so far, if we click in one of the agents here, oops, we can go to the turtle and ask to inspect that turtle. We've seen that before. I just don't know where the, oh, it's here. We drag it back. So as you can see here, we can, the turtles, they basically have some properties here. And these properties, they're standard for all the turtles, like all of this, like a hull, color, heading, X core, Y core, shape, up to pen mode. But sometimes, like depending on the code, you need to add stuff. You need to make sure that the turtles have more properties than the standard ones because you need them to make your context work. We're going to learn how to do that. Before then, I want to talk about like a global variable. So we have two kinds of properties. We have the properties who are like shared with all the agents, and the observer or the turtles, they all have access to these variables. And to declare them, we call them globals, okay? So to declare global variables, we can, let's say, we can create a global variable called wealth here. That's going to be the wealth of the whole group of people in our model. And this wealth variable here, it can be changed by the turtles or by the observer. Anyone can change this variable because it's a global variable. So let's just say at the setup here, before you create the turtles, we are going to set the wealth variable to 100. So that means that every time we start the code, the overall wealth is equals to 100. Okay, that's just a way of doing that. And let's say that at the go button, we ask all the turtles, besides moving and turning right, we're going to ask them to set the wealth to the previous wealth plus 1. So every turtle is going to set the wealth a little more. So it's going to increase the wealth as we go. So that means like that here we are talking about the observer. Here we're talking about the turtles. Both of them have access to the global variables. We can even create other global variables. Let's say like jobs, like the number of people employed, or let's say here incomes, like a sum of incomes, and so on and so forth. So we can create as many global variables we want. And the important thing to know is that these variables are accessed by basically everyone. Okay. So if I come here, let's just go back to the model and click on setup again. And there is a way to check these variables. So I can come here and just type print wealth. And that's going to show us that the wealth is 100 because that's how much wealth we've declared at the beginning. But if I click if I call the procedure go here, we know that at the go procedure, each turtle basically increases the wealth by 1. So if I print the wealth here again, I expect it to be doubled, like it to be 200 now, and it is, because every time I've called, like every time I call go, I basically increase my wealth in 100 because it's the number of turtles we have. Okay, so those are like global properties that can be used for a lot of stuff on our code. Another thing we can do also is to give like attributes to the agents. As I've said, like the agents, sometimes they need specific attributes that are not the generic attributes they have from the beginning. And to do so, we have the keyword turtles own. So turtles own a lot of stuff. The turtles can own, for instance, an income. The turtles can own a gender. The turtles can own a job. The turtles can own an age. So you can add like as many attributes as you want for the turtles. And of course, we always check here to see if the code's right. But the interesting thing here is like when you click setup here, and when you inspect one of the turtles, let's inspect this turtle, not 95 here now. You will see that besides all the attributes we had before, we have now income here, gender, job, and age, they are all 0 because we didn't initiate any of them. We didn't declare like the initial values, but they are here, and basically you can see the attributes added to the turtle's info properties. Another way of inspecting turtles is like inspect. You can also like ask to inspect the turtles from the command center. I can say like, I want to inspect one of the turtles. So it can be any turtle, it can be random. It's gonna open here the box again for us. The same way as using the right click on the mouse and going on inspect. Okay, just so you know. All right, so as we've seen, like we can make some changes from this income. So let's remove the other attributes here. Let's say like we set the wealth as 100 at the beginning, and let's say that the turtles, when they are initiated, we set their wealth, their income. So each turtle has an income, and this income is going to be a random number from 0 to 100. So it's a random value from 0 to 100. Okay. And let's say that like every time we call the turtles, instead of adding 1 here, we're going to add wealth plus income. So here the turtle is changing the global variable using their individual property, the attribute income here, that's random. Okay, so in that case, what we have here now, it's like if you click on setup again and you click on go, and at any point we want to print the wealth, we're going to have a very big number, because every time you run the code, the wealth increases because the person gets more income, and this goes on top of the rest. Okay, another way of showing these things instead of printing all the time here is by creating plots. So we can come here on plot, we can click on add a plot, and then let's put a plot in here. A plot is basically a graphic. It's going to be a graphic, and it's going to show like whatever you want. So I want to show the global wealth. Let's say I want to show the global wealth. So the x-axis is time, and the y-axis is the wealth. Let's say here we can just like yeah. And here basically you have the color of your graphic that you can change. I'm going to put a red just because it makes it more interesting. And here you basically give the command to plot something. In this case here, the standard plot is the number of turtles, but I want to plot the wealth and how it evolves over time. So if you click on apply and OK here, let's just make this graphic here a little bit bigger. And if now we click on setup and go, it should be showing the graphic in there. It's not showing. I don't know why. So let's find out what's going on here. Plot wealth should be plotting. It's a line.
Shouldn't be some wealth person or something like that?
No, the wealth is a global variable. I can put some here. Let's see if it works, but that's like that's not how it should go. Or maybe, oh yeah, maybe I just need to know it should outscale. Okay, plot, well, let me see here, plot count turtles. Let's see if it's showing there. Let's see if there is a, yeah, I think that net logo is broken here because it's not even showing the standard stuff. Let's see if I'm missing something here. Name, max, show legend. Yeah, there's something wrong about net logo in here. It's not like a, let me try to change the color here just to see what happens. I think there is something wrong. Let me try to this shouldn't make any difference, but you never know. Okay, so let's save it. Let's close NetLogo. Let's open again. Let's see what happens. That's why it's important to save things. Let's see here. No, it's not showing. It's not showing even the standard one. It's quite weird. Let me just change this to 100. Yeah, it's not plotting for some reason. Some random reason that I don't see why. Okay. Anyways, it should work. If you test in your computer, it might work. And yeah, let's leave it for later. It wasn't even part of my schedule here, but try to add just to make it more fancy, and didn't work. All right, so we were talking about global variables, attributes for the agents, and that's basically how it goes. Another important aspect in here that we didn't talk about yet, it's about the ticks. And the ticks, they're basically the time control of the code. Oh, and that's why it's not plotting. We found out. What happens here is like you see that the ticks here, they're not set. So there is no time schedule, and the plot works on top of the timestamps of the code. So for the ticks, for the time counter, we always should, like by the end of the setup code here, we should put a reset ticks code here. And the reset ticks basically says like a reset and start the time counter. So now if we go back here and click on setup, you're going to see that the ticks will reset to 0 here. Now we have a time, we have a clock that's going to count the time for us in here. And by the go command, we mostly 99% of the codes, we just give the command tick here. Tick command basically says like, look, I finished one time step, increase the counter, please. So let's save this thing, let's set up, and let's go. So now we have a code. So if I go here now and edit it and ask it to plot the wealth, it should be a linear increase. So you see that the wealth is increasing as time goes by. And you can also see that the timestamp here, it's basically the time of the ticks in here. So like it means that we've run 4278 time steps in this simulation here. Okay, and then the graphics working now. Can we change it? Yes, we can change. Like let's say we want to use some conditional command. I want to count only the wealth of the rich people. So when we create the income here, let's say we set the random income for people at the beginning of the setup. And we can also do this. Like we can say like if the income is higher than 50, let's say these people are like the rich people. So we're going to set their colors to red, okay? So that's how we're going to do it. So if the income is higher than 50, let's set the color to red. And let's say like the whole wealth, like from everyone, it's going to be, of course, the wealth of all the agents. So we should start the wealth as 0. We're going to put the wealth in here. So first thing on setup is to set up the overall wealth to 0. And as we set the income from people, we are going to set the wealth as a wealth plus income. Okay, that means that by the end of the setup, the global wealth is going to be the sum of all the incomes from everyone. Like we're going to have like the initial income. Let's do better. Let's just remove this from here and leave the initial income as 0, and just keep this here, because this command here basically increase the wealth by the income of the people, okay? So the setup basically sets the wealth to 0, create 100 turtles, set the standard color to blue, the shape to person. It sets an initial income as a random value between 0 and 100. It's going to be between 0 and 99. And if the income is higher than 50, it sets the color to red. And on the go function here, we are going to ask the turtles to move forward, to move right. And let's do something interesting here. Let's say if the color of the turtle is red, okay? If the color of the turtle is red, then we are going to increase this wealth. Let's just include it here. Then we're going to sum up the wealth of the people. So basically here what we're doing is like we are counting the wealth only of the rich people to the sum of the total. So like if the person's income is less than 50, it's not considered to be calculated in the whole income here. And let's see what happens with our graphic now. So if you click on setup, you're going to see that some people are red because they have an income higher than 50. And if you click on go here, you're going to have the same linear situation, but now like we have only the wealthy people. We can also add some chaotic stuff in here. So we can like simulate like the situation when a person, for instance, loses a job or loses the income. Like it's not, income is not like stable for everyone. So we can even ask like, let's say each person is gonna have their wealth. Like so we're gonna set the income. They're gonna have the income set to income plus a random number. Let's say we want to make a random number between like the person can win or lose, let's say 10 on their income. So we can say here like a random 20 minus 10. So that this number here is going to basically say that it's going to be a random value between 0 and 19. And that means that if it's 19, the person's got it, so it should be 21 here. Let's put 21. So that means that the numbers are going to vary from, then let's just keep it 20, it's fine. The numbers are going to vary between, like when the random number is 0, it's going to be minus 10, so the person's going to lose 10. And then it's 20, let's say the person's going to gain 10 on their income. So this is going to basically create some randomness and the code that's going to change the income. And we should also check if the income is higher than 50, then we should set the color to red. As usual, we can even use an if else here. And elsewhere, we're going to set the color to blue just to keep it consistent. So if people change their income, if they increase or decrease, they change colors as well. Let's see if this is all good. Netlog says it's all good. So let's run. And then you're going to see that people are going to change also their colors. And as they go, like, let's just see here, like some people are going to change their colors as they change their income as well. Okay, I saw 1 or 2 changing colors so far. And then the code works like that. Just notice that the graphic is not linear anymore. It's tending to make a little curve in here. And that's because basically the incomes are not stable anymore, so they change over time. Right? Any questions so far on this topic here? So if there are no questions, we can move forward. And this is going to be like the last bit of our lesson. And I want to create with you a model to find a target. The idea here is basically we have like a maze, and we have an agent on a maze, and the agent's trying to find the target. There is a place where the target is, and the agent's going to move around the maze trying to get the target. So we're going to start like a new code in here. We're going to start from 0 from scratch, and we are going to go to the code tab as it should be, because we should do stuff on the code tab, because that's the place. And I just want to start like introducing some new stuff in here as well. Like we've been working with Turtle so far, and Turtles is a generic name like for the agents on that logo, but you can define the name for your own agent. Okay, to do so, we have the keyword called breed, and breed basically says like, look, I'm creating a new type of agent, and we've been working with people, so like I can create a breed that's people. So people is going to be like the agent set. When you have like multiple agents, the plural is going to be people, and one specific agent is going to be a person. So that's basically like you're defining like I created a new type of agent. I'm not working with turtles anymore. I'm working with people and person. Let's just like create the setup, remembering always to clear all at the setup and to reset the ticks at the end of the setup, and the code is going to be somewhere in the middle here. We also have the go procedure, and the go procedure usually finishes with tick, which is basically to count one time step. And what we want to do in here is basically create a maze first, and then after we create a maze, we create the agent, we create target, and we then on the go procedure, it's going to be the action basically. So the initial scenario we want to build here is a maze. We want to create a maze, and we want to create one agent. Okay, so to do a maze, like we have many things we can do. I'm just going to drag this a little bit here so we can see. But the first thing I want to do is like when we create a maze, like the world starts all black. That's the color of the patches. And to define the maze, I'm gonna color the patches in a different way so we can put obstacles. The obstacles are like the walls on a maze. And the first thing we have to do here, I'm gonna create a slider here. Should be showing here. Nope. Oh, I have to create an ad. It's not a button I want. It's a slider, and this slider here I want to create it. And this slider is going to be called like number of obstacles. Okay, the number of obstacles can be minimum 0, increments of 1. The maximum here is 100. Let's just keep it like that. Let's see what happens here. Later we can change this. Okay, this variable here basically says like how many obstacles we're going to put on the world. If we check the characteristics of the world here, we're going to see that we have 16 by 16. The world is 16 by 16, which makes like the world 33 by 33. Oh, sorry, it's not 16. It's like from 16 to minus 16 on the x-axis, and the same for the y-axis. So the world is 33 by 33, which is going to be more than 900 like we have more than 900 patches in here. Okay, so we can even increase the number here later. Let's just keep it 100 for now. So this is going to be the number of obstacles we have. First thing I want to do on the setup button, I want to ask all the patches to change their P color to white. And we can save, check. Let's save this code here. Let's call it maze. Saved it even in the wrong place. It's fine as well. And we missed the setup button in here. So let's put the setup button. Let's add the go button as well. Let's make sure that the go button is forever. And let's just move some stuff around here to make them more aesthetically pleasant. So when I click on setup here, it changed the color of the world to white. So it's basically doing what we need. We're asking the patches to set the P color to white. So when we click on setup, the patches are changing their colors to white, which is fine. Now, the next step is basically to create the obstacles. And to create the obstacles, we're gonna take advantage of the random commands on that logo again. So we're going to ask n of. N of basically is a command that says like I want to select randomly n, like n, and then here of course it's a variable n number n of something. So this command here, the first thing you have to put is the number of obstacles. So I could put here, if I put 20, I'm just saying like I want to select 20 of something. It can be 20 turtles, it can be 20 patches, it can be 20 anything. But here I want to select num obstacles. So basically here we are saying like I want to ask n of number of obstacles patches. So I'm selecting them, like in this case here, 50 random patches, and I'm asking them to set the P color to red. Okay, so what this does is basically like we set all the colors to white, and we take the number of obstacles variable in that slider in the interface, and we select that number of patches to set the color in red. So when we click on setup here, you can see that what's it doing is basically coloring everything in white and creating the obstacles in red. Okay, so now we know that like 50 might be too few, so we can go back on the slider here. Let's increase this thing here. Let's put it 900, the maximum, and let's start with like 200 obstacles. And when we do that and click on setup, we're going to see that we have many more obstacles than we had before. Let me just make it 100 here. Oops. 100. So then we click on setup. It has like 100 patches are going to become red. And of course, as we increase this thing here, you're going to see that more and more patches, they become red. Like we are not going to have all red because we have more than 900 patches in the maze, but like you can slide it like here. And let me just do something here. Let's put this like on 400 here, just because after 400, I believe that you can find a way to the target. Yeah, 400 is quite a nice number. So let's just put it back here. So we've created the color of the background, we've created the patches, and now it's time to create the agent. Okay, so we are gonna, on the setup, we are gonna create, before we were creating turtles, you remember, but now we don't have, like we don't have turtles anymore, we have people. So let's create people. One. So I'm creating one person here. And as we've done before, like we're going to give some commands straight away after that person is started. And let's just like set the size of that person to 1.5. And this is gonna increase the size of the agent shown on the interface tab. Let's set the color. Oops. Let's set the color to green. So the agent is going to be green. Let's set the heading of the agent to 0 degrees. So agents are initiated heading up. And we are going to create a Boolean variable here called finished. It's going to be false. And this variable here is true when the agent finds the target. So that's basically how it goes. So when the agent finds the target, the variable is going to be set to true. Okay, so I have the reset ticks in here that initiates the model. And that's basically how we start. Oh, I forgot one detail here. It's basically the target. So to create the target, we basically have to ask one of patches to set their P color to, let's say the target's blue, okay? So when we, oops, the finish here is not created. So notice that like if you try to move to the interface tab and there is an error in your code, it's not going to let you at first. So it's just saying that nothing named finished has been defined. And that's quite correct, because basically we created the people here, but we forgot to say that people on the attribute finished, okay? So this is like an individual attribute of people. And who are people? Like it's the breed we've just created in here. Now, like if you check here, oops, it's not finished. It's finished, and it's finished here as well. So let's check. Now it's all correct. Let's save, go back to the interface. So now when we click on setup, it's going to create the obstacles, they are red, and the target's the blue box. Okay, so we have a blue square, which is basically the target. And the green arrowhead is basically the person. And this person is seeking the target. So that's how it's going to be. Like our code aims to create a model where the person is kind of looking for the target. And when the person finds the target, the simulation is over. The objective is accomplished. Any questions in here? So far, so good. All right. So we've created the setup procedure. Now we have to create the go procedure, which is basically where things are going to happen. And in this procedure, like we have to ask people, which is basically our agent, to do some stuff in here. So like they have to move around the maze in such a way that they can get to the target. But there is one special thing here, like we only move the person if the person is not finished. So like if the variable from the individual is not finished, that means that the person didn't find the target yet. So if the person's not finished, some stuff are going to happen in here. And the first thing that's going to happen is like if we're going to make sure that like if the person has like if the person is locked, let's say like in this case here, let me just force it. Like if the person is in front of an obstacle, like if the person is heading towards an obstacle, a wall, the person has to turn and go another way. It doesn't make sense for the person to just keep like on that same place. So what we're doing here is like if the P color or if the patch color of the patch ahead, one step forward of that turtle, if that color is red, that means like if there is an obstacle in front of the person, then the individual should rotate right 90 degrees. So that's how it goes. Like if you bounce on a wall, you rotate right 90 degrees. So next time you can move forward without like getting stuck on that block. So that's the first thing we're going to do. So if the P color of the patch ahead is red, we rotate 90 degrees. But if it's not white, okay, sorry, if it's not red, we can even create an if else here. So let's say if else. Oh no, it should, yeah. Yeah, so let's put an if else here and see how it goes. So no, let's do it simple so I don't make it even more confusing. So if the P color of patch ahead one is different from red, then you ask your agent to move forward one step. So if it's okay to go ahead, like if it's not an obstacle, like you can move forward one. So that's how it's going to be the movement of the agents here, and that's how it's going to be. So if the agent's not finished, it can move forward or rotate 90 degrees if there is an obstacle in front of him. So let's just comment this thing. So if there is an obstacle ahead, turn right. If there is no obstacle ahead, move forward one. Okay, and there is like there is a special situation here that's like when the agent lands on the target. So if the P color of the patch here, and then now it's not patch ahead, it's patch here, meaning like it's the patch where the agent is in. If this color is blue, meaning like the agent's landed, like has landed on the target, then you set the finished variable to true, and that's how it goes. All right. So that's what people do basically. They check if they have an obstacle ahead. If there is no obstacle ahead, they move forward, and if they are like on a blue spot, they set the finished variables to blue. So in this case here, agent is on a blue patch, meaning the target. And by the end here, before you ask all the agents to move, like if all people have finished, so if all people have finished, we stop the simulation. And that's basically how we end the simulation, so it doesn't keep like going on and on and on, even after people found the target. And then we have the tick here to increase the time. So here, like this is a sentence. If all people fulfill this command here, then it does the stop, and that's how we expect this thing to work. So here we can do the setup, and I'm gonna reduce the time here so we can see the agent moving around. So it's gonna move around. When it bounces on an obstacle, it goes right, and you can see that the word's not wrapped, so it basically goes like goes from top to bottom, and the agent's gonna be basically moving all the way. If I increase the time here, we're gonna see that eventually it might find the target. Let's just like move it really quick here. It's not finding, which is interesting. So sometimes the way the obstacles are created, they're not gonna allow the guy to find the obstacle. It can happen. So let's increase the number of obstacles here. Click on setup and see if it finds it now. Yeah, no success. And it's easy to not have a success, guys, because basically our agent's a bit dumb, right? Like the intelligence here is very little. He's basically just like bounce on the obstacles and go right. So depending on the configuration of the maze, like it's not gonna find the obstacle. So let's just try less dense one here. Let's see if it finds. No, it won't. Like in this case here, it's stuck in there. Okay. So that's basically how it goes. So it's, as you can see, it's stuck, and it's okay that it's stuck. Okay, it's fine, because that make room for us to extend the model and basically fix it in such a way that it works as we expect. So do you have any suggestions about how can we change the behavior of the agent, the people agent here, the person, in such a way that it can behave better and find the target easier? Do you have any suggestion?
You can paint the path that he already worked. So if he turns right and see that he already walking that path, he doesn't follow that way. He changes his direction again.
Okay, that's a way of doing so, but then just observe that if you keep doing that, the agent might be like let's say in a dead end very soon, because you keep coloring the paths and don't let him go back. It might be that it might end like in a dead end surrounded by colors that he can't move anymore. Do you agree with me, Rolf?
Yes.
So it's possible, but it's not ideal, because we can create, like, we solve one problem but we create another one. Any other suggestion there for fixing
because
this?
you are always moving 90 degrees, you could make it random. Because I'm seeing that all the last three tentatives were a loop.
Okay,
So trying to choose one time 120 and another 90 or another 180, maybe
okay.
it could unlock it somehow.
Okay. So the thing is, we want the agent to always work up, down, left, or right. That's how it should work, actually. But you're right. Like the fact that the agent's always going 90 degrees to the right is not quite what we expect it to be. Okay. So if we create some randomness, like if from time to time the agent just go towards another direction randomly and not just keep following the 90 degrees to the right all the time, maybe we can twist the situation here. So that's one possibility. Let's try to see how it goes and if it works. So let's say here, so we know that like if the color ahead is red, the agent moves right 90 degrees. It moves forward 1 here. But let's just increase like let's just do like this. Look, if let's create a random float here. Random floats like it's a command that's going to create a random number that's going to be a float. If you put 1, it's going to be between 0 and 1. And the numbers can have decimals. So it can be 0.1, 0.2, 0.00001, and so on and so forth. So let's give a 1% chance, 1% chance for the agent to move randomly towards somewhere else, okay? So in that case, let's just, let's rotate, let's put left. Let's say the agent goes left 90 degrees, okay? Just change the direction here so it doesn't, it goes somewhere else. Let's see what happens in here. I'm not too confident that this is going to work, but yeah, it found the, I don't know if you saw, but like it found it. So if like now look, when the agent's moving, what happens like with 1% of chance, instead of turning right, the agent's going to just turn left. And by just doing that, we fixed the problem. So sometimes you don't need, sometimes like when you do agent-based models, simple solutions can solve the problem. You don't even need to go that complex. Like let's see now. Like now you can see that sometimes it goes left, and now it's finding the target quite constantly. Like let's try again. This is just the beginning, and let's put it through to find the target again and see how it goes. So you see, like it was stuck, like going straight, and randomly it just turned left. So it basically breaks the pattern we've created, and eventually it might find a way to get to the target. Yeah, it found the target. All right. So this is our first model doing together in this lecture. Like that's basically the model to find a target. We've learned how to create a grid. We've learned how to create attributes for the agents, how to access the attributes for the agents, how to use them to make decisions. We've learned about random values on NetLogo. So we've learned about random, which is basically like what's the name of the integers, like integer numbers. We've learned about random floats, which is basically random float numbers. We've learned about conditionals, and we've learned how to access some attributes of the patches and of the agents as well. And with no further ado, I think that's it. If you have any questions, feel free to ask. Otherwise, this is basically the end of this lesson, and then I'm going to finish the recording, then we can talk about the bureaucratic part of the course. No questions?
No, thank you.
Okay, so that's it. See you next lecture. Let me just